So we start off with fractions. There are three types of fractions, namely common fractions, decimals, and percentages. So whenever we write a number like 1 over 2 and 3 over 4, they are common fractions. We write them as one number over the other. Numbers like 0.5 and 0.75 are decimal fractions. We write them with a decimal point. And then with the percentages, we write 50%, 75%. So we write them with the percentage sign. Okay, so when we simply say fractions, we usually mean common fractions. Decimal fractions are often just called decimals. So under the common fractions, the word fraction refers to part of something. If, for example, a quantity is divided into 3 equal parts, then each part is said to be a third of the quantity, written as 1 over 3. A fraction such as 2 over 5 or 2/5 means divide an amount into 5 equal parts and take 2 of those fifths. Numbers like 1 over 3 and 2 over 5 are common or vulgar fractions. We write them as one number over another. The top number is called the numerator. The bottom number is called the denominator. The denominator gives you the name of the fraction. It tells you how many equal parts there are in the whole one. The numerator tells you the number of these equal parts you are dealing with. So for example, 3 over 5 means 3 out of 5 equal parts. 4 over 7 means 4 out of 7 equal parts. 2 over 9 also means 2 out of 9 equal parts. And then it goes on. Under the common fractions, we have proper fractions. And then a proper fraction is a fraction in which the numerator is less than the denominator. We move to the improper fraction. It's opposite with the proper fraction. The improper fraction has its numerator greater than the denominator. And then we move to like fractions. Two or more fractions are said to be like if they have the same denominator. Unlike fractions have different denominators. And the mixed numbers contain both whole numbers and fractional parts. So when we see here, proper fraction, we said the numerator is always lesser than the denominator. So 2 over 3, 4 over 5, 3 over 7, they are all what? Proper fraction. And then improper fraction, always remember that the top number is bigger than the bottom number. It makes it improper fraction. Okay, so we have like fractions. Because denominators are all the same, we call it like fractions. And then unlike fractions, numerator and denominator, they are all not the same, so they are unlike. And then we have mixed numbers. The whole number, which is 3 whole number, and then a fraction, 1 over 4. 2 whole number, 1 over 5. They are mixed numbers. And then we have decimals, 0.5, 0.75, 0.125. Whenever you say point, mention the number one after the other. So it shouldn't be 0.75, just 0.75. So 0.125. Let's say 0.3268. So 0.3268, not 0.3268. No. Okay, we have percentages, so 50% and 75%. Okay. So when we have a question like this, what fraction of the whole figure does the shaded part represent in each of the following? It's very simple. So you need to just count the divided portions. So let's start from here. 1, 2, 3, 4, 5, 6, 7, 8. Then you bring the over sign and then you count the number of shaded regions. 1, 2, 3, 4. So it's 4/8. And then when you are told to simplify to the lowest form, you just use 4 to multiply through. So 4 goes here 1 and then goes here 2. 1/2. Okay, so let's move to the next one. We need to count the whole boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So denominator is 10 over what? The regions are shaded. 1, 2, 3. 3/10. The same thing applies to this. 1, 2, 3, 4. So over 4. How many regions are shaded? Just 1, 2, 2. So these will be your answers. We move on to equivalent fractions. So equivalent fractions are fractions that have the same value but look different. So we had the word equivalent from the word equal. Okay, so identical. So equal numbers, identical numbers makes up equivalent fractions. So for any fraction, an equivalent fraction can be formed by multiplying the numerator, that is the top number, and denominator, that is the bottom number, by the same number. Okay, so let's see for this example, and then you know what I'm talking about. So let's say we have 3/4. We will want to multiply the numerator, the top number, and then denominator, the bottom number, with the same number, which is 3, and see what happens. Okay, so 3/4. 3/4. We are multiplying it by what? 3. So 3 times the 3 over 4 times that same number 3. What are we going to get? 3 times 3 is what? 9. 4 times 3 is what? 12. And then we can have another example. But this time around, we are going to multiply the same 3/4 with this number 4. So 3/4. 3 times the 4. 4 times the 4. 3 times 4 is what? 12. Over 4 times 4 is what? 16. So I can show you that 9/12 is the same thing as 12/16. Okay, let me show you. 9/12. When you are told to bring it to a simplest form, you will get a number that will be able to go through the 9 and then at the same time the 12. And then I think 3 will do, right? So 3 times what number will give you the 9? Let's go back. So 313, 326, 339, 3412, 3515, and so on. Okay, so what we mean is one number multiplied by the 3 will give us the 9. So 313, 326, 339, 9. So that means 3 goes into the 9 3 times. And then one number, when multiplied by the 3, will give us the 12. The same way. 313, 326, 339, 3 4 12, which is what? 4. We have what? 3/4. Okay. All right. So let's see. 12/16. The same process. Let's see, what number do we think? Okay, let's try to use 4 and see. 4 1 4, 4 2 8, 4 3 12, 4 4 16, 4 5 20, and so on. So 4 times what number will give us 12? So 4 1 4 4 2 8, 4 3 12. So 4 goes here, 3. And then the same way, 4 1 4 4 2 8, 4 3 12, 4 4 16. So 4 times 4 give us what? 3/4. We found a 3/4. So that means 9/12 is equivalent to what? 12/16. The same fractions. Hope you got it. Yeah, all right. And then we did multiplication. Okay. And then let's move on to dividing. And so we say dividing the top and bottom of the fractions by the same number also makes an equivalent fraction. This process is often known as cancelling. So, for example, 3/12. Or we can write the same thing as 3 divided by 12. Okay? All right. So we want to cancel 3/12. 3 goes into 3 how many times? 1. It goes into 12 how many times? 4. So we have 1/4. And then it's said to be what? Equivalent. And then we move on to another example. 8/10. So we are canceling. We are saying that division and that equivalent fraction can also be called canceling. So we are just canceling. And then one number will be able to go through 8 and then 10. I think 2, right? So 2 goes here, 4 goes here, 5. We have one, 4/5. So division and the equivalent fraction can also work, and then it's called canceling. We are going to simplest form, or what is normally termed as lowest form. So canceling common fractions is also called simplifying a fraction. The equivalent fraction has smaller numbers in it. Therefore, a fraction is in its simplest form or lowest terms if it cannot be reduced any further. A simpler form of any fraction can be found by dividing the numerator, that is the top number, and denominator by the same number. The number must be a factor of both the numerator and denominator. Okay, so let's see. For example, we have 24/36. And then we want to simplify to the lowest form. So let's see what number can go through 24 and then 36. Let's see 2, right? 12 can also do it. 4 can also do it. Ah, let's start with 2. So 2 goes into 24 how many times? 12. And 2 goes into 36 how many times? 18. We can still go on and then simplify it. But the same number 2. 2 goes into 12 how many times? 6. 2 goes into 18 how many times? 9. We can still go on. And this time around we can't use 2 because 2 can go through 6, but it can't go through 9. So let's try 3. Yeah, 3 can do it. So 3 goes into 6 how many times? 2. It goes into 9 how many times? 3. Now we can further simplify. So our final answer will be 2 over 3. So 2 over 3 is said to be the simplest form of 24 over 36. Okay. Normally, mathematics, we have two methods of always solving a problem. So if you're not okay with it, you can go with the highest common factor. So let's say the same question 24 over 36, you want to get to the simplest form, okay? And then you don't like the idea of cancellation, so you want to go with the HCF. So we move to see the highest common factor of 24 and then 36. So I think 1 is a factor of 24, 2, and then we have 3, we have 4, we have 6, we have 8, we have 12, and then 24. And then we have 1 for 36, we have 2, we have 3, we have 4, we have 6, we have 9, we have 12, we have 36. So we are looking for the HCF, highest common factor. So looking through, I think the highest common factor will be 12. Okay. All right. And then we bring the 12 to divide through. So 12 and then 12. So 24 divided by 12 is what? 2. And then 36 divided by 12 is what? 3. So you see we've arrived at the same 2 over 3 in a short period. So you can choose to pick this or pick that. Okay. And then someone may ask, how do you just jump? Maybe you've forgotten of the basis. So we could go on the long division route for you to remember. So um, 24 will go into it, and then 12. So 12 times what number will give you 24? So again, 12, 1, 12, 12 to 24. So we've had it, so 2. Okay, 12 times 2 is 24. You are down, so 2. That's why we have 2. And then the same way we do for the 36. Okay, so 36 will go in, and then we use the same 12. Okay, so 12 times what number will give us 36? So 12, okay, we already did it here. So 12 times 12. 12 times 1 is 12. 12 to 24. 12, 3, 36. So 12 times 3 will give us 36. So that is why we had the 3 here. So with more examples, let's see. So we are told to write the following in lowest terms. So we jump to the constellation. What number will go through 10 and then at the same time 12? Always ask yourself that question. So 2 can do it. You can start from 1. No, 1, no. You move to the next number 2. Okay, 2 can do it. Then you go for 2. So let's see, 2 times what number will give us the 10? So it's 5. 2 times what number will give us the 12? It's 6. Can we further simplify it? No, because there's no number to go through 5 and 6. So our final lowest term will be 5 over 6. Okay, we move to the second question. 7 over 14. What number can go through 7 and then at the same time 14? 1, let's move on. 2. Okay, let's see. 2 times what number will give us 7? No. 3 times what number will give us 7? 4 times what number? So it goes on, goes on. So let's quickly do it. So 7. 7 goes into 7. How many times? 1. It goes into 14. How many times? 2. So final answer will be what? 1 over 2. Why? Because we can't continue to simplify. This is the final lowest term. So 1 over 2 or half. And then let's move on to the last question. Let's see. 2 2 can go through 12, but no, not 15. So let's see. 3. Okay, 3. 3 goes into 12 how many times? 4. It goes into 15 how many times? 5. So final answer is what? 4 over 5. Why? Because it cannot further be simplified. So 4 over 5. These are some of the questions you find at the HESI exam. So find the value of n in the following. Usually is letter x, but I'm using n. So 3 over 4 is equal to 24 over n. Okay. Sometimes the question could be like 3 is to 4 is equal to 24 is to n. Do not panic because it's the same thing. Okay. You can either switch it to this way, or if this is very simple for you, then you turn it to this way and then you work your way out. When it's in this form, always that first number or letter is multiplied by the last number or letter. And then the second number or letter is multiplied by whatever thing that is close. So this is how it goes. Always remember that the first goes through to the last and then the second goes through the closest number there. Okay. All right. So when it's in this form too, you just do cross multiplication. So we're looking for n. So 3 times the n. Okay. Then you bring your equal sign, and then 4 times 24 or 24 times 4. It doesn't matter. It can be 4 times 24 or 24 times 4. Okay, so 3 times n will give us 3n is equal to 24 times 4 will give us, so 4, 4, 16, 6, 1, 4, 2, 8, 9. Okay, how did I get out? It's simple. So 24 times 4, okay? So 4, 4, 16, 1, 4, 2, 8, plus this, 9, 96. Okay. And then we need an n. So we have to multiply through by the 3. 3 goes here, 1 goes here, 1. 3 goes into 96. So 3 goes into 9, 3. It goes into 6, 2. So 3 goes into 96, 32. So our final answer will be what? N is 32. Okay? Okay, so if it's in this form too, what you can do is we are looking for the n. So you always have to make sure that comes first, then equal sign, and the other numbers follow. So 3 times n, then equal sign, then 4 times 24. Okay, so 3 times n, and then the same way 96 multiply through the same, and 32, n is equal to 32. So Do not confuse yourself. It's the same way. Okay. We have the second question. 3 over 5 is equal to n over 15. So just like the first question, you could be given um, a question the same way as this. 3 is to 5 is equal to n is to 15. So again, I said the first number to the last, the second number to the closest number or the letter. Okay. All right. So cross multiplication, we need the n. So 5 times n is equal to 3 times 15. So 5 times n is what? 5n is equal to 3 times 15 is what? So 5, 3, 15, 5, 1, 3, 4, 45. How did I get that again? 15 times 3. 3 times 5 is what? 15, 5, 1, 3 times 1, 3 plus 1, 45. 45. Okay. Okay. And then the 5 will multiply through. So 5 goes here 1, goes here 1. 5 goes here 1, goes here 9. Because 5 times 9 will give us 45. So our final answer will be what? 9. Okay. The same way. Okay, let's do it quickly. So we need an n. So that means we'll bring the first 5 times n is equal to 3 times 15 will give us 145. Okay. Multiply through, multiply through. So n is 9. Okay. All right. And then also we have a simplest way, because if you are running out of time, you could just go through like this. 3 over 5 is equal to n over 15. So you look at the question, okay? Okay, you look at it, you analyze it. What number was used to multiply 5 to get this 15? Okay, so 5, 3, 15, right? So that means we multiply 3. That's how we got this. Then the same number can be multiplied to get the n. So then 3, 3, 9. So n is 9. Then quickly you get your answer, you just pick it and you move on. That is the fastest way to go about this. Okay? All right. You could be given a funny, confusing question like this. 3 over x is equal to x over 12. Sorry about that. Let me change this and to x. Okay? All right. Just to confuse you, so 3 over x is equal to x over 12. Do not panic because it's very easy. Okay? All right. So the same process, cross multiplication, we need an x. So it always will come first before the equal sign, and then the other numbers continue. Okay? All right. So x times the x then is equal to 3 times 12. Okay? So x times x is what? S squared. 3 times 12 is what? 36, right? Okay. So x, we need an x. And then this squared will change to what? The square root. You put a 36 in there. So what is the square root of 36? It's 6. Why? Because 6 times 6 gives us what? 36. The same number times the same number. That means the square root. Okay? You see how simple it is? All right. Um, let's do the same thing for 2 over x is equal to x over 8. We need an x, so it will come first. X times x is equal to 2 times 8. Okay, all right. X times x is what? S squared is equal to 2 times 8 is what? 16. Then we move on to x. We move this squared and change it to what? The square roots. Put a 16 in. So the final answer will be what? S is equal to what? 4. Why? Because the same 4, when we multiply it, we will get what? 16. That means the square root. Okay? All right. So when you get question like this, do not panic. It's very easy. Continuing, there can be a question like this: reduce the following fractions to their simplest form. Right, so we have 25 times 21, all divided by 7 times 5. So as I said, in mathematics, we always have two methods of solving a question or a problem. Sometimes it could be even three. And then the advanced mathematicians could even have 4 or 5 methods of solving a question. Okay, so with this purposes, I'll just be going by only two methods. Okay, so um, the fastest way is to use a calculator because you are dealing with a time. And so you just punch in 25, okay, times the 21. You get what? 525 over 7 times 5, 35. Then quickly you go 525 divided by 35. So final answer is 15. Okay, that's the fastest. But then you can also go by this way, or 25 times 21 over 7 times 5. Okay, so let's see. 7 goes here 1, it goes here 3, and then 5 goes here 1, 5 goes here what? 5. So 5 times 3 is what? 15. 1 times 1 is what? 1. But then we pick what? The whole number 15. So you see we have the same. So both methods are very easy. So you pick whatever thing that works for you. We move on to comparing and ordering fractions. So to compare fractions of the same quantity, we use the symbols, that is the less than and then the greater than. Okay. So I remember when we were a kid, what we used to teach us, for you to remember greater than and less than is your right hand is always what? Greater, and then left is what? Less than. Okay, so this greater, this the less. Okay, because what we are taught is left hand is always um of great less importance compared to the right hand. So right hand is always greater than the left hand. Okay, all right. And also what you could use to remember is L stands for left, so left hand. And then definitely if it's not left hand, it's what? Right. So right hand is greater, left hand is less. Okay, so fractions with the same denominator are simple to compare. They are the same kind of fractions. Okay, so for example, when we have 2 over 5, 3 over 5, 4 over 5, we know what is greater than the other, okay, because they all have the same denominator. And then we can compare them using the sign, less than or greater than sign. This is what we call ordering or arranging them in ascending order or increasing order of magnitude or size, starting with the smallest. Okay, so we could write this as 4 over 5 is greater than 3 over 5. And then 3 over 5 is greater than 2 over 5. Very easy. Okay? All right. And then when we are going vice versa, 2 over 5 is what? Less than 3 over 5. And then 3 over 5 is less than 4 over 5. Okay? Now we have to know that ascending order of magnitude means from the smallest number to the largest, and descending order of magnitude means from the largest number to the smallest. Fractions with different denominators are different kinds of fractions. To compare them, write them with the same denominator. This is often called the common denominator. We can use equivalent fractions to do this. Okay, so one way of finding the common denominator to multiply all the denominators. Now, for example, when you are given 1 over 3, 1 over 2, 2 over 5, 1 over 4, and then you are told to arrange them from ascending to descending or from descending to ascending, whatever the question is. Because these numbers 1 over 3, 1 over 2, 2 over 5, 1 over 4 have different denominators. We can't just move on and then group them from ascending to descending or descending to ascending per the question. So what we need to do, we have two methods again. So I'll start with the first method and I'll jump to the second method, and then whatever works best for you, you choose it. Okay, so with the first method, we have to multiply 3 by the 2. It will give us what? 6. And then the same 6 multiplied by 5 give us what? 30. And then 30 multiplied by 4 give what? 120. Okay? All right. So right now we have the same common denominator to be what? 120. Okay? All right. And then we move on to what number multiplied by this 3 will give you the 120. When we get that number, we multiply with the what denominator. Okay. Okay. So let's move on quickly. So 3 times 40 will give us what? 120. So that 40 will be multiplied by the 1, which will give us what? 1 over 3 is now what? 40 over 120. I hope you understand. Okay. And then we move on to 1 over 2. So what number multiplied by the 2 will give us 120? It's 60. So we multiply the 60 by the 1. So 60 over what? 120. We move on the same way. 5 times what number will give us 120? And then we use that same number to multiply the 2. Okay. All right. So let's use calculator so that we quickly run through. So 24. We multiply 5 by 24, we get what? 120. So we multiply that 24 by the 2. Okay. Give us what? 48 over what? So 2 over 5. Now we have what? 48 over what? 120. Okay. And then the last one number multiplied by 4 will give us the 120. Then 30. So 30 times the 1 is what? So 1 over 4. So 30 times the 1 is what? 30 over what? The 120. Okay. Right now, for 1 over 3, we have what? 40 over 120. 1 over 2, we have what? 60 over 120. 2 over 5, we have what? 48 over 120. 1 over 4, we have what? 30 over 120. So right now, it's very easy for us to what? Compare them and then order them from ascending order to what? Descending order. So right now, we are we're gonna check it. What number is the least? 40, 60, 48, 30. It's 30. And then 30 goes for what? 1 over 4. So our final answer will be 1 over 4 is definitely less than. Remember, left hand is what? Less than. Right hand is what? Greater than. So from ascending, 1 over 4 is less than. We look for the next least number. 48, 60, 40. And then 40 is equivalent to what? 1 over 3. So 1 over 3, and then 1 over 3 is also less than what? 48, which is equivalent to what? 2 over 5. And then last 2 over 5 is also less than what? 1 over 2. So this will be our final answer. Okay. And then with the same numbers, 1 over 3, 1 over 2, 2 over 5, 1 over 4, I will work this with the second method so that you compare with the first method and then you choose what best works for you again. Okay, this time around, we are not multiplying 3 by 2 and then what we get by 5 and then what we get by 4, which we arrived at what? 120. This time around, we just go through and then find the LCM, least common multiple. And then if you've forgotten about least common multiple, you can comment and then I'll go through that, okay? But if you remember, I think we can quickly go through and then I think we should get 60, okay? All right. So then 3 times what number will give us a 60? So I think 20, and then we multiply the 20 by the 1, which is what? 1 over 3. Now we'll get what? 20 over what? The least common multiple, which is what? The 60. Then 1 over 2, 2, the same way. One number will go to 60 when multiplied by 2. I think 30. So we multiply the 30 by the 1, just 30 by the least common multiple. We move on to the next one, 2 over 5, the same way. 5 times what? 12. 12 times 2 is what? 24. And then 60. And then the last one, 1 over 4. Okay. Then 4 times what number? Let me use a calculator. It missed me. So 60 divided by 4, 15. So 15 times 4 will get us what? 60. So the 15 times the 1, 15 over what? 60. Okay, so right now 1 over 3, we have 20 over 60, 1 over 2, we have 30 over 60, 24 over 60, 15 over 60. So let's arrange them from ascending order to descending order. So looking through, I think 15 is the least. So 1 over 4 is less than 20. 1 over 3 is also less than. And then 24 follows. 2 over 5. And then the last one is less than what? 1 over 2. So there's our final answer. And then when you compare this to the first method that I went through, you get to know that we have the same what um, answer. So whatever works best for you, you choose it. Okay. And then we have to know that the smallest fraction is the one with the smallest numerator. And then the largest fraction is the one with the largest numerator. Okay, write it down. So notes is very, very important. So the smallest fraction is the one with the smallest numerator. And the largest fraction is the one with the largest numerator. Okay, all right. And then if the numbers are not common fractions, first put them in common fractions before you start working. Okay, all right. So I will give you examples with that. And then you are given a like example like this. Arrange these 0.2, 1 over 4, 30%, 10%, from ascending to descending order. You can't just start working on them unless you put them into the same fraction form and then also have the same denominator, so 0.2 will be 2 over 10. This is already in fraction, so 1 over 4. This will be 30 over 100. This will be 10 over 100. Okay, right now we have to look for either the least common multiple or multiply 10 by 4, then what we get, multiply through 200 and then the same 100, and then 2 will go into what that number that we had, the final number, what number will go through with a 2. When you get that number, you multiply with a 2. Okay, the same thing, 1, 30, 10, and then you have the same denominators, and then you'll be able to go through. Okay, if you don't understand this, please comment and then I'll get into it more. And we will have a question like this: which fraction is greater? So just as we did with the first, let's use that method, the first method. Now we multiply 18 by 6. So 18 times 6 will give us what? 18 times 6 will give us 108. So we have 108 here. And then 18 times what number will give us the 108? When we get that number, we multiply it with the 3. Okay. All right. So 108 divided by 18, we get 6. So 6 times 3 is what? So 3 over 18 is now 6 times 3 is what? 63. 18 over what? 108. And then the next one is what? 2 over 6. So one number multiplied by the 6 will give us 108. It's 18, and then we use the 18 to multiply the 2, give us 36. So 36 over what? 108. Okay, now the same denominators but different numerators. And then if you remember, I made mention that whenever a numerator or numerator is less than the other, that means that very fraction is what should be brought first, because if you are working from ascending, that will be the first, and then we move on. So this question is, which fraction is greater? 18 over 108, 36 over 108 is definitely 36 over 108, so 2 over 6. So our answer will be what? 2 over 6. Okay, and then the same way, 4, 6, 24. We have 24. Move on. So 4 times what number will give us 24? 6. 6 times 1 is what? 6. So 6 over 24. 1 over 4 is 6 over 24. And then we move on, 2 over 6. So 6 times what number will give us 24? 4. And then that 4 will multiply the 2. So 4 to 8. So 8 over 24. And then the question is asking for the greatest among these two. Now 8 over 24 is the greatest. So 2 over 6 will be our answer. And then the last question, 5 says 30. Okay, we have 30. So 5 times what number will give us 30? 6. That 6 will multiply the 2. So 2 over 5 is to 12 over the 30. And then 2 over 6. This times what number will give us 30 is 5. And then we multiply that 5 by the 2. 5 to 10 over 30. Which is the greatest? Definitely 2 over 5. Okay, so yeah. Okay, so I'll continue and then work the second method and see if we will arrive at the same 2 over 6 for the first question, 2 over 6 for the second question, 2 over 5 for the third question. So the second method, this time around, the second method, we are using the LCM. So the LCM for 18 and 6 is what? 18, right? Okay, so we have 18. 18 goes into 18 how many times? 1. We multiply it by the 3 over 18. So 1, 3, so 3 over what? The same 18. Okay, and then 2 over 6. 6 goes into 18 how many times? 3. And then 3 to 6. So 6 over 18. 6 over 18 and then 3 over 18. Which is the greatest? Is 6 over 18. So it's equivalent to what? 2 over 6. So the first method and then the second method do work. Okay, let's move on to the second question. The least common multiple for 4 and then 6 will be what? 12, right? Okay, so 12. 4 goes into 12, 3, 3, 1 over 4. So we multiply the 3 by the 1. 3 over what? The 12. Okay. All right. Then 2 over 6. Then 6 goes into 12 how many times? 2. So 2 times 2 is what? 4. So 4 over 12. 3 over 12 and 4 over 12. We made mention that whenever the numerator is larger, that means it's what? The greatest between the two, or the greater between the two. So 4 over 12, that means the same way 2 over 6. So the last question, um, between this, the least common multiple, look at it, think we'll get 30, right? Yeah, so 30. 5 goes into 30, 6 to 12. So 2 5, you get 12 over what? 30. And then 6 goes into 30 how many times? 5. So 5 to 10 over what? 30. Between them, there is the greater. So we pick 2 over 5. So yes, both methods work. Which one works best for you? Choose that one. Now we go on to mixed numbers and improper fractions. And we can change an improper fraction to a mixed number and vice versa. So for example, we have 13 over 3. How do we change this to mixed number? We go by the long division, okay? So denominator will be out and then numerator will be in. Okay, so 3 times one number will give us 13. So 3 times 4 will give us 12. It's close, so we pick the 4. 3, 4, 12. Okay, subtract 1 because we want a mixed fraction which includes a whole number in a fraction. We'll pick this. We will maintain it this way. We will not continue um, with working it out. So 4, final answer will be 4, and then this will come here 1, then over the 3. We've turned 13 over 3 to a mixed number, which is what? 4 whole number, 1 over 3. Okay. And then also another example, 7 over 4. The same process, 4, and then the 7 will go in there. So for 4, 1, 4, 4, 2, 8, so we pick 1. 4, 1, 4. Subtract 4 from 7, you get what? 3. Okay. So our final answer will be 1 whole number, 3 over 4. Okay. And then also we can change mixed fraction to improper fractions. Okay, that is very straightforward. So we have example 7 whole number 2 over 3. 7 whole number 2 over 3 to improper fraction. So what happens is 3 times 7 is what? 21. Okay, and then you add a 2 plus 2 all over what? The denominator. So final answer will be what? 23 over 3. So from mixed number to improper fraction. Okay, I think we have another example. So 6 whole number 3 over 5. 6 whole number 3 over 5. The same way, 6 times the 5 is what? 30. And then we add the 3 all over what? The denominator 5. So final answer will be 33 over 5. Mixed number to improper fraction. We jump to addition and subtraction of fractions. Fractions can only be added or subtracted if they have the same denominator. That is, if they are like this, 1 over 8 plus 2 over 8, then you can go on and then add, okay? Also, 1 over 8 minus 2 over 8. You can go on and then do a subtract, okay? But then if we have something like 1 over 8 plus 2 over 4, you can't add them. You have to change um, 8 and then 4 to have the same denominator like this before you can go on. And then the same way applies to this. 1 over 8 minus 2 over 4. No, we can't continue. Okay, we have to change the denominators. Okay. Okay, so an example like this, 1 over 2 plus 2 over 5. You see, we can't continue to add them because it has different denominators, which is 2 and 5. We have to get the same denominator, then we can continue to go ahead and then, um, do the addition. So quickly, the common denominator will be 10. Again, if you've forgotten about how to find it, let me know under the comment section, and then I'll teach that whole thing. Okay, so it's 10. Then 2 will go into 10 how many times? 5. Multiply that 5 by 1. 5 plus 5 goes into 10 how many times? 2. 2 to 4. So we have what? 9 over 10. Our final answer. Okay. Then let's see, we have another example here. We have 3 over 4. So 3 over 4 plus 7 over 8 plus 1 over 2. Okay, so we have to change the denominator for A2 to be the same denominator, then we can go on to work it out. So quickly, we can have 8 to be the common denominator. So 4 goes into 8, 2, 3 times the 2 is what? 6 plus 8 goes into 8, 1 times the 7 is 7 plus 2 goes into 8, 4. 4 times the 1 is what? 4. So 6 plus 7 is what? 13. And then 13 plus 4 is what? 17 over 8. Okay. All right. So there is you can move on if you want to. If the question asks you to um, get the last answer to be a miss number, then you have to go ahead and then go through the long division. So 8 will come out and then 17. So 8 times what number will give us the 17? So 8 to 16 and 1. So 2 whole number, 1 over 8. Okay. Let's see if we have another example. Okay, so now we have mixed numbers and then we are told to add them. And then before we go on, we have two methods. I will teach the first one and then we go to the second one and then you pick whatever works best for you. So with the first method, we have to change the each mixed number to an improper fraction. And then we go ahead and then work it out. So 3 times 2 is what? 6 plus 1, 7 over 2 plus 3 to 6 plus 2 is what? 8 over 3. Now the common denominator that we will get from this is 6. So 2 goes here, 3, 3, 7, 21 plus 3 goes here, 2, 2, 8, 16. Then we move on, we finalize it, 21 plus 16. So 7 and then 3 over 6. Final answer. Okay. And then the second method, we can go on but then again, if you are told to change it to a mixed number, you have to change this. Okay. So the long division as usual, 6, 37, 6, 6, 6, 36. So 1. So 6 whole number, 1 over 6 will be our final answer. Okay. Now let's see the or the second method. So 3 whole number, 1 over 2 plus 2 whole number, 2 over 3. Okay. So first of all, we add the whole numbers, 3 plus 2. And then we go on 1 plus 2 and then 2 and then 3. Okay, so 3 plus 2 is what? 5. And then we have to look for the common denominator, which is 6. 2 goes here, 3, 3 plus 3 goes here, 2, 4. Remove 1, 5. 3 plus 4 is what? 7 over 6. Okay, all right. And then now we are looking for the same answer. So 6, 5, what? 30, and then 37 over 6. Now when you change it to the mixed number, we still have 6. Okay, so with these two, you pick whatever works best for you. So again, remember that whenever there is a mixed number, it is probably easier to change it to an improper fraction before performing the operation. So let's try these two examples for subtraction since we did some examples for addition. So the same process, we try to get the same denominator. Then this will be what? 12. Okay, 4 goes into 12, 3, 3, 3, 9, minus 3 goes into 12, 4. 4 times 1, 4. Final answer is what? 5 over 12. Okay, all right. So we have to change mixed numbers to what? Improper fraction before we proceed. So 326 plus 1 is 7 over 3 minus 4 times 1 4 plus 1 5 5 over 4. Okay, then we look for the same denominator, which is 12. So 3 goes into 12, 4. 4 times 7, 28 minus 4 goes into 12, 3. 3 times 5, 15. and then last um, step is we subtract 15 from 28. So 5 from 8 is 3, and then 1, and then 12. So this will be our final answer. And then if you want to change to a missed number, you know how to go about it. So 12, 13, 12 goes here, 1, 12. So we get what? One whole number, 1 over 12. Okay. All right. Now let's use the second method and see if we arrive at the same one whole number, 1 over 12. So first of all, 2 minus 1, the whole numbers will go, and then 1 over 3 minus 1 over 4. So 1, we look for 2 minus 1 is 1, okay? Look for the same denominator. 3 goes here, 4. 4 minus 4 goes here, 3. 3. So 1 whole number, 1 over 12. So we arrive at the same answer. Okay. Now we move to multiplication of fractions. So to multiply two fractions, multiply top numbers, that is the numerators together, and bottom numbers together, and cancel if possible. Mixed numbers must first be changed to improper fractions before multiplying. So always know that when it's addition and subtraction, multiplication, even division, you have to change mixed numbers to improper fractions, and then it will be very easy for you. So first example, 1 over 3 times 4 over 5. So we are told to multiply this. Very easy. It says we should multiply the numerators and then denominators. And then if possible, we can cancel. So 1 times 4 is what? 4. Over 3 times 5 is what? 15. We can cancel, so this will be your final answer. Okay. Okay. And then let's see, we have 2 whole number, 1 over 3 times 1 whole number, 1 over 2. Okay, so we have different methods of solving mixed fractions or mixed numbers. So first of all, we as we are told, we have to change it to improper fractions. So 3, 2, 6, 7 over 3 times 2, 1, 2 plus 1, 3 over 2. Then 7, 3, 21 over 6. Okay, all right. Another method, we could have just 3 goes here 1, 3 goes here 1, and then our final answer will be what? 7 over 2. Okay, because if we should cancel this, we will arrive this. Let's do the try and see. So 3 goes here 2. Okay, it goes here 7. You see, we have the same 7 over 2 here. Okay, all right. We move to division of fractions, and then in this type of fraction, in order for us to divide a fraction, okay, with a second fraction, we have to turn it upside down. So let me give you an example before you proceed to multiply through. Okay, so let's say we have a question to be 1 over 3 divided by 2 over 5. Okay, a question like this, we can't just continue working unless we change this from the denominator needs to be the numerator, and then this 2, which is numerator, needs to be denominator. So 1 over 3, and then we have to change this sign to what? Multiplication sign. So whenever you change it, know that we are changing the second fraction. Okay, so 5 over 2. Then lastly, 1 times 5, 5 over 3 times 2, final answer. Okay, all right, another example. And then also know that whenever you have a mixed number, you need to change into improper fraction before you proceed with this method. Okay, so um, we need to change from mixed numbers to improper fractions. So 3 times 7 is 21 plus 1 is 22. Then over the 7 divided by 4 times 7 is 28. And then 28 plus 5 is 33 over 7. Okay, then we can go on and multiply, change this division sign to multiplication, and then also change 33 over 7 to what? 7 over 33. Okay, so 22 over 7 times 7 over 33. Okay, and just go ahead and multiply 22 by 7 and then 7 by 33 and then also cancel. And then another method I taught, 7 goes here, 1 goes here, 1. Okay, so 22 times 1 is 22 over 1 times 33 is what? 33. Okay, and then I think 11 can go through. So 11 goes here, 2. 11 goes here, 3. So final answer will be 2 over 3. Okay, all right. And then we move on to this question. You shouldn't panic about this question. This 4 is also, so 2 over 5 divided by, so this 4 can also be written as 4 over 1. Okay, all right. So quickly 2 5 times, then we switch 1 over 4. 2 times 1 is 2 over 5 times 4 is 20. We can go ahead and then simplify. So 2 goes here, 1 goes here, 10. Final answer is 1 over 10. So the next topic will be order of operations, still under fractions. But before we go on, let's take a note of these word here. Okay, so whenever you have um, a problem like this, 2 over 5 plus 8 over 5, and then denominators happen to be the same, you can just go ahead and then work it out. You pick one of the denominators, which is 5, you add the numerators. 2 plus 8 is 10. You go ahead and you do any cancellation. If there is here, there is. So 5 goes here, 1 goes here, 2. So we have 2 over 1, which is 2. Okay. But then if we have different denominators, 5 and 3, you can't just go ahead and work it out like we did with the first one. You need to find the LCM first. Okay. So LCM for 5 and 3 is 15. And then 5 goes into 15 how many times? 3. And then you multiply the 3 plus the 2, 6. 3 to 6 plus 3 goes into 15 how many times? 5. Then 5 times 8, 40. Okay, so 6 plus 40 is 46 over 15. If there is any cancellation, you just go about it. So I hope you've noticed the difference. The same thing applies to subtraction too. So since there are same denominators, we pick 1 5 and then we just go ahead and then subtract 2 minus 1, which is 1. So final answer will be 1 over 5. The same way we can go ahead and then work it out because these have different denominators. So we have to find the LCM, which is 15. 5 goes into 15, 3, 3, 2, 6, minus 3 goes into 15, 5. So 5 times 1, 5, and then you subtract 5 from 6. So you get 1 over 15, final answer. Okay, so we need to take notice of these differences. And then when we come to the division part, 2 over 3 divided by 6 over 2. So you can't just work it out. You need to change the division sign to multiplication and then also change denominators and then numerators. So 2 over 3 times 2 over 6. Okay, and then you can go ahead and do any cancellation. So 2 goes here, 1 goes here, 3. So final answer will be 2. 1 times 2, 2 over 3 times 3 is what? 9. So 2 over 9. Okay, all right. And then we have 2 over 3 times 6 over 2. You just go ahead and work it out. So if there is any cancellation, you just go ahead and then you do it. So 2 goes here, 1 goes here, 1. 3 goes here, 1 goes here, 2. So 1 times 2, 2. 1 times 1 is 1. Final answer is 2. So we need to take notice of these. Okay. So with order of operations, we follow the BODMAS, which is normally said board maths. So what it means is whenever you have a problem like we have on the board, one whole number 2 over 3 minus into bracket or bracket open or parentheses open, one whole number 3 over 4 divided by 2 whole number 5 over 8, parentheses close or bracket close. We need to follow board maths. So we'll first of all deal with the B, which is the brackets or the parentheses, and then O is off. Off also means multiplication. Then we deal with division, we deal with multiplication, we deal with addition, and then subtraction. But then you have to know that before you start dealing with a BODMAS, whenever there is a missed number, you need to change it to improper fraction before you jump to the board maths. Okay, so let's see. Let's work this out. Now there are missed numbers, so we need to change them into improper fraction, and then we go ahead to follow the board math. So 3 times 1 is 3 plus 2, 5. So 5 over 3 minus 4 times 1, 4 plus 3, 7 over 4 divided by 2 times 8, 16, 16 plus 5. Let me get a calculator. 16 plus 5 is 21. So 21 over 8. Okay, so now we're done with moving or removing mixed numbers to improper fraction. The next step will be we have to deal with the parentheses, okay, the B or the brackets. Okay, so 5 over 3 minus 7 over 4 times, we are changing the divisions times, and so the denominator 8 will come up and then 21 down, so that we can do any cancellation. So 7 goes here, 1 goes here, 3, 4 goes here, 1 goes here, 2. So we have 5 over 3 minus 1 times 2 is 2 over 1 times 3 is 3. Now we can go on and then work this out. We have the same denominators, 3, 3. So we pick 1, 3, and then we just go ahead and then subtract 2 from 5, which is 3. Now we can go ahead and then do any cancellation, which is 3 goes here, 1 goes here, 1. We have 1 over 1, which is 1. This will be our final answer. We have another question on the board. 2 whole number 1 over 3 plus 1 over 2 of 3 whole number 1 over 3. Okay, so as we said, we will take off all the mixed numbers into improper fraction. So 326, 7 over 3 plus 1 over 2 of 339, 10 over 3. Okay, and then right after that, we will look for brackets B. We don't have any bracket, so the next will be O, which is off. Off also means multiplication, so we will deal with this. Okay, All right, so 7 over 3 plus 1 over 2 times 10 over 3. And then since we are dealing with this, we need to put bracket and deal with it. Okay. All right. So 7 over 3 plus. Now let's see if there is any cancellation. 2 goes here, 1 goes here, 5. So we have 5 over 3 because 1 times 5, 5. 1 times 3, 3. We have the same denominator, so we can just pick 1, 3, and then add 12. We can do cancellation. 3 goes here, 1 goes here, 4. So we have 4 over 1. Final answer is 4. We have another interesting question on the board. Bracket open, 1 over 4 plus 1 over 2 bracket close divided by 5 over 12 of one whole number 1 over 5. So we are still following the BODMA. So with this, we need to change any improper numbers to improper fraction before we move to the BODMAS. So 1 over 4 plus 1 over 2 divided by 5 over 12 of 5 times 1, 5 plus 1, 6 over 5. Okay. All right. Then we come back to the BODMAS, which is bracket. So let's work this bracket. All right. Different denominators. So we have to find the LCM, which is 4. 1 plus 2, 2. Now we have 3. 1 plus 2, 3 over 4. The rest divided by 5 over 12 of 6 over 5. Okay, so off we are dealing with this. That will be the next one to deal with it. Okay, so 3 over 4 divided by 5 over 12 times 6 over 5. Off means multiplication. So let's do cancellation. 5 goes here, 1 goes here, 1. 6 goes here, 1 goes here, 2. So right now we have 3 over 4 divided by 1 times 1, 1, 2 times 1, 2. Okay, go ahead. 3 over 4 times 2 over 1. Let's do any cancellation. 2 goes here, 1 goes here, 2. So our final answer will be 3 times 1, 3 over 2 times 1, 2. 3 over 2 will be our final answer. We have a question on the board. Let's work it out. So 339, we change all mixed numbers to improper fraction before we continue. 339 plus 1, 10 over 3 minus 2, 2, 4, 5 over 2 divided by 5 over 2. Okay, so we are working 10 over 3 minus 5 over 2, and then we'll come to the 5 over 2. Okay, all right, so we find the LCM, which is 6. 3 goes into 6, 2. 2 LCM is 6. 3 goes into 6, 2. 2 times 10 is 20. Minus 2 goes into 6, 3. 3 times 5 is 15. So we have 15 from 20, we get 5 over 6. We have 5 over 6. So 5 over 6 divided by 5 over 2. Okay. All right. Let's write it this way. 5 over 6 divided by 5 over 2. And 5 over 6 times 2 over 5. Cancellation. 5 goes here, 1 goes here, 1, 2 goes here, 1 goes here, 3. So we have 1 over 3. That's our final answer. So with this question, I will try to work it in two ways. So I will try to work it normally, and then the second method I will follow the BODMAS strategy. And I just want us to know if we arrive at the same answers. Okay. All right. So first off, I'll decide to just work this. LCM is 4, 2 minus 1. So we have 1 over 4. We added 2 plus 1 over 8. All, okay. So 16, then 8. Now we have LCM to be 8, 4, 2, 2 plus 8, 1, 1. So we have 3 over 8 over 8 over 16. We can write it 3 over 8 divided by 8 over 16. 3 over 8 times 16 over 8. So let's see if we can do any cancellations. So 8 goes here 1, goes here 2. 2 goes here 1, goes here 4. So we have 3 times 1, 3 over 1 times 4, 4. This will be our final answer. Okay, so let's try to work following the BODMAS. Okay, so this time around, let's try to follow the BODMAS. Okay, so the first answer we had 3 over 4. Let's see for the second answer by following BODMAS. Okay, so there are no brackets, there are no off multiplication, division, this, but that will be the last. Okay, multiplication, nothing, addition. So let's start working with addition first. All right, so 1 over 2 minus 8, 4 goes into 8, 4, 1, 4 to 8, then 2 plus 8 goes into 8, 1. Okay, and then we have 3 over 8. So we can write it 1 over 2 minus 3 over 8 all over 3 over 16 plus 5 over 16. Okay, now let's see what else. After addition, then subtraction, but we still have another addition here before subtraction. So let's deal with this. Okay, we pick the same because they both have the same denominators. We pick 16 and then add 8. So we have 8 over 16. So right now we have 1 over 2 minus 3 over 8 all over 8 over 16. Now we can move on to the subtraction. LCM is 8, 2, 4, 8. So 4 minus 8 into 8 is 1 times 3, 3. We have 1 over 8 because 4 minus 3 is 1. Okay, so now we have 1 over 8 all divided by 8 over 16. And then we can write it this form 1 over 8 divided by 8 over 16. Okay, let's just continue here. Okay, so 1 over 8 times 16 over 8. We can do some cancellation. 8 goes here 1, goes here 2, 2 goes here 1, goes here 4. 1 times 1 is 1 over 1 times 4 is 4. So our second answer we had 1 over 4. So you see, first answer we had 3 over 4. Second answer we had 1 over 4. And then if a question like this is given to you, and then the options, we have option A to be 3/4, option two, B to be 1/4, and then, okay, let me write it here so that it becomes easy for us. Okay, so A 3/4, B say 1/4, C let's say 3/8, then D let's say 2/2. Okay, so you have a question like this, and then after working, let's say you didn't follow the BODMS, and then you had your answer to be 3/4. You pick A, and then it'll happen that you'll be wrong. Okay, and then you'll be losing marks. So you need to follow the BODMS, and then you arrive at 1/4, which is the correct answer. Okay, we move to the next topic. Finding the fraction of a quantity. Okay, so to find the fraction of a quantity, multiply the quantity by the fraction. Okay, all right. So, for example, we have 1/3 times, let's say, $30. Okay, what you need to do is just cancel through. 3 goes here, 1 goes into 30, 10. So, final answer will be what? $10. All right, let's see another example. So, we have 1/5 times $250. The same process, 5 goes here, 1 goes into 250, 50 times. So our final answer will be $50. Okay, like this question in a school, 7/10 of the peoples like maths. Half of those people who like maths are girls. If there are 240 peoples altogether in the school, how many girls like maths? Okay, so with this question, you need to write it in a mathematical way. Okay, and that is what we are doing under finding the fraction of a quantity. Okay, so first of all, how many peoples like math before we come to the girls? Okay, and then it said in a school, 7/10 of the peoples like math. Okay, so how many people? So peoples will be 7/10 times, you are giving the approximation of the whole people together to be 240. So 240, then you work this out. Here you can do some cancellation, and then 7 times 24 is 168. Okay, we have 168. Now we can go ahead and then look for the number of girls who like maths. Okay, okay, so girls. Let me get a calculator. Okay, so girls, it says what is the half? Okay, so here's the tricky part. Half of those people who like math are girls. Okay, so the half of them times our 168. Okay, all right. So 68 divided by 2 will be 84. Okay. All right. That will be our final answer. So we move to express one quantity as a fraction of another. Okay, so when you want to do that, you have to know that a quantity A as a fraction of another quantity B will be written as A over B and then reduced to its simplest form. So in numeric, let's say we have 2 over 4. 2 goes here, 1 goes here, 2. We have 1 over 2, or what we call half. Okay, and we should know that the quantities must have the same units of measure before we proceed working them out. So it's best for you to choose the units that you find very easy for yourself. Okay, like for example, 8 centimeters as a fraction of 200 centimeters will be written as 80 over 200. Then we will reduce it. 0 cancel 0, 2 goes here, 4 goes here, 10, 2 goes here, 2 goes here, 5. So our final answer will be 2 over 5. Okay, all right. And then also know that to express 40 centimeters as a fraction of 2 meters, first change either 40 centimeters to the meters, which will be 0.4. Okay, all right. Or you change 2 meters to the 200 centimeters. Okay, all right. So let's say we have a question like this, 40 centimeters, and then you are to change to meters. Okay, first of all, you have to switch the centimeters to be what? Meters. So 40 centimeters to meters will be 0.4 meters. And then you can proceed and then you work it out. Okay, all right. So let's see. We have to know that the number which follows off or comes after the um, word off is always the denominator. Okay, all right. So 80 centimeters as a fraction of 200 centimeters. So off, the number that is coming right after the off is always the denominator. So even if off is here and then 80 was to follow, 80 would have been what? The denominator. Okay, all right. I'll give you an example and then you know what I'm talking about. Okay, so what fraction of 1 minute is 45 seconds? Before we work this out, we said earlier that all the units needs to be the same before you can proceed to work. Okay, okay, so we need to change the minute to seconds and then we can just work them out. Okay, so how many seconds will give 1 minute is 60 seconds is equal to 1 minute. Okay, all right, we've gotten 60 seconds and then we have 45 seconds. But then we made mention that the number that comes right after off here will be the denominator, and then 1 minute is now 60 seconds. So the 60 will be the denominator, and then 45 will be up there as the numerator. Okay. Okay, so let's use 5 to cancel through. 5 goes here, 9 goes here, 12. 3 goes here, 3 goes here, 4. So our final answer will be 3 over 4. So we have example 2. What fraction of 600 grams is 500 grams? Okay, so first off, we need to check the units if they are the same. If they are, then we can just proceed working. If they are not, we need to change uh, from one unit to another unit. The simplest unit we can work our way out. Okay, so this time around we have grams and then grams. They are all of the same unit, so we just continue working. And then the second thing we need to study is off is here, 600 is here, so 600 will be the denominator, and then 500 will be up. Do some cancellation, 0 cancel, 0 cancel, final answer is 5 over 6. So we jump to word problems. Then some problems actually require good knowledge of fractions, okay, to work them out. So let's see this example. Um, a rod is 10 whole number 7 over 8 meters long. So 4 over 9 of it is cut off. What is the remaining length? With this, we have two ways of solving it. I'll give the first method and then also the second method. And then you pick whatever works best for you. Okay, so first off, 4 over 9 of 10 whole number 7 over 8. So 4 over 9 times 10 whole number 7 over 8. We'll change this mixed number to improper fraction. So 4 over 9 times 87 over 8. Then we see 4 goes here, 1 goes here, 2. Okay, let's get a calculator and see if we can cancel 9 and 87. So 87 divided by 9. And we get a decimal number. So 87 over 9 times 2 is 18. So 18 divided by 87 divided by 18. We have so we can go ahead and then do cancellation by with 3. Okay, so 3 goes into 18 6 times, it goes into 87, 29. So 29 over 6. Okay, all right. And then right after that, that wouldn't be the final answer. Now it said a rod is 10 whole number 7 over 8 meters long. And then we've worked for 4 over 9. Okay, so we need to subtract what was cut off from the rod, from the full length, which is 10 whole number 7 over 8. So we write the full 10 whole number 7 over 8, and then now subtract what we had, 29, which is what was cut off, over 6 from the 10 whole number 7 over 8. And then we continue to work it. 80, 87 over 8 minus 29 over 6. So common multiplication, LCM between it will be 48. So 8 into 48 is 6, and then 8 times Okay. Okay, so LCM for 8 and 6 will be 24. Okay. Okay, so 8 goes into 24, 3, and then 3 times 87, and times 87 will be 261, minus 6 goes into 24, 4, and then 4 times 29 is 116. So you subtract 116 from 261, get 145 over 24. And try to divide it by 24. Okay, so 145 divided by 24. So you get 6 whole number 1 over 24. This will be our final answer. Okay, so I'll go ahead and then continue to work the second method. Then you compare the two. Then you pick whatever works best for you. Okay, so with the second method, we will represent 1 whole number as 10 whole number 7 over 8. Why? Because it's one full rod, so 1. And then we will subtract 4 over 9 from it. And then whatever answer we will get, we will multiply it with 10 whole number 7 over 8, and then arrive at the same answer we had for the first method. Okay, all right. So 1 whole number minus 4 over 9. Okay, so we can also write it 1 over 1 minus 4 over 9. 9, 9, minus 1, 4. So 5 over 9. We have 5 over 9. And we come 10, 7 over 8 off the 5 over 9. So 10 over number 7 over 8 times 5 over 9. We change mixed numbers to improper fractions. So 87 over 8 times 5 over 9. Okay, let's see if we can do some cancellations. So 3 will go into 9, 3, and then go into 87, 29. Okay, all right. So 29 times 5 give us 145 over 8 times 3 is 24. And then 145 divided by 24. With a long division, we will get 6 whole number 1 over 24. So as we see, we arrived at the same answer. So you pick whatever method works best for you. So we have another example. A length of 7 over 8 centimeters is divided into 8 equal parts. I. What is the length of each part? I. How much does one division differ from 1 over 8? So let's work for the I first. So we need to change word problems to mathematical statements before we can work them out. So right now it said, what is the length of each part? Okay, and then it said that a length of 7 over 8 is divided into 8 equal parts. So equal can be each. So length of each part, A. So what is the length? 7 over 8 of each part divided by the 8. I hope we understood that. Okay, so 7 over 8 divided by 8 can also be written as this 7 over 8 divided by 8 over 1. Okay, so 7 over 8 times 1 over 8. 7 times 7, 7. 8 times 8, 64. Okay, so 7 over 64 is the length of each part. And then we move to II. How much does one division differ from 1 over 8? Okay, so II. Now we've already worked out and then realized that 7 over 64 is um, of each part. Okay, and right now it's asking us for the differ from 1 over 8. So it's very simple. We just subtract the 7 over 64 from the 1 over 8. Okay, so 1 over 8 minus 7 over 64. And then we just work it out. Okay, so we find the LCM, which will be 64. Okay, so 64, 8 goes into 64, 8, 8 times 1, 8, minus 64 goes into 64, 1, 7, so 1 over 64 will be our final answer for how much does one division differ from 1 over 8. Okay, so fractions spent and fractions left. We are always interested in finding how much we spend on the original amount of money, how much is left, and what we can do with the fraction left. The original total amount is equal to 1. That is total fraction. Therefore, to find the fraction left, subtract the fraction spent from 1. Okay, all right. So whenever you want a total of something, just represent it by 1. So let's say $500 can also be what? 1. Okay, 1 over 1, which is 1. Okay, when we are dealing with fraction, as I told you, whenever you see a word problem, you have to change it from the word problem to a mathematical statement so that you can work it out. Okay, so with this question, Mr. Ford withdrew some money from the bank. He gave 1 over 2 of it or half of it to his son and 1 over 3 or 1/3 to his daughter. If he had $500 left, how much did he take from the bank? Now we want to know how much Mr. Ford took from the bank. So let's first of all deal with what Mr. Ford gave to his son and then daughter. So he gave half of the money to his son and then 1/3 to his daughter. So let's add in. Okay, so 6, 2, 2 goes into 6, 3. So 3 plus 3 goes into 6, 2, 2. So 5 over 6. We have 5 over 6. Okay. All right. So 5 over 6 of the total amount is what Mr. Ford gave to his son and then daughter. Okay. All right. So we are going to represent 1 over 1 or 1 to be what? The $500. Okay. All right. So 1 minus, let's subtract the 5 verses from it. Get 1 over 1 minus 5 over 6. So 6 goes here, 6 minus 1, 5. We have 1 over 6. Now we know that $500 and $500 is also 1 over 6 as a fraction. Since we have it this way, then it's very easy for us to work our way out to know the total money he took from the bank. Okay, so again, we want the whole number, which is the whole money Mr. Fogg took from the bank. So we will represent it with 1 over the 1 over 6. Okay, and then we will multiply it $500. Okay, all right, so 1 over 1 divided by 1 over 6. We can turn it to be 1 over 1 times 6 over 1. So right now we have 6 over 1. Okay, so if we have 6 over 1, we multiply it by the $500. 6 times 5 will give us 30. We added 2 zeros. So 1, 2, 3. So Mr. Fogg actually withdrew $3,000 from the bank. We have another example under fractions spent and then fractions left. So a boy spends 2 over 7 of his pocket money on transport and 1 over 5 on sweets. I. What fraction of his pocket money does he spend on transport and sweets? I. What is the fraction left? Very simple. So first off, let's deal with the I. It's like what fraction of his pocket money does he spend on transport and sweets? So the boy spends 2 over 7 of his pocket money. Okay, we don't know the whole amount, but he spends the 2 over 7 of that amount on transport, and then also 1 over 5 of that amount on sweets. So we just add them. Okay, all right. So because he said what fraction of his pocket money does he spend on transport and sweets? So we want to know. So 2 over 7 plus 1 over 5. Okay, so 35, and then 7 goes into 35. 5 to 10 plus 7, 7. Okay, so 17 over 35 will be our answer. Okay, what is the fraction left? Okay, so we don't know the fraction that is left, but remember that we said we represent the total money or total number with what? 1 or 1 over 1. Okay, so it's asking of the fraction left, so we represent it 1. I mean the total pocket money 1, and then we will subtract 17 over 35 from the 1. Okay, and then we will get to know the fraction left. So minus 17 over 35. Okay, so this can also be written as 1 over 1 minus 17 over 35. 35. So 1 goes into 35, 35, 35 times 1, 35 minus 35 goes into 35, 1. 1 times 17 is 17. And when we subtract 17 from 35, 35 minus 17, 18 over 35. So what is the fraction left? The fraction left will be 18 over 35.